NCERT and Cbse 9th standard for mathematics and science. So in this session we are going with a very important topic, that is algebraic identities. So in the previous sessions we have covered problems until the factor theorem, that is we had solved many problems they are related to factor theorem in the previous session. So in this session we will be going with the most important section, that is algebraic identities. So in your 8th standard classes you have come across many identities related to algebra. In arithmetic also you have come across many formulas. So there is a difference between an entity and a formula here. So let me define first what is an entity and then we will see what is a formula, right? So an entity is an equality, or an entity is a mathematical statement which is true for all the values of the variables which are involved in it. So they are called as entities. So we have n number of entities, many entities which can be used wherever we want during computations in mathematics. Other part of that is formulas. For example, for simple interest we have some formula, that is SI is equal to PTR by 100, and in arithmetic of 10th standard class we are going to come across Sn is equal to n by 2 into 2a plus n minus 1 into d. So in arithmetic we come across many formulas. So here formulas are the mathematical statements which gives the relationship between the terms which are involved in the formula, involved in that mathematical statement. But here in an entity it is an equality where, or a mathematical statement which is true for all the values of the variables involved in it, right? So now you may ask me, sir, what is the use of identities in algebra? So why we need identities? So one first most important point regarding identities is that identities, when used during the computation or when we compute the mathematical steps one by one, so these steps, when we involve entities in doing these steps in mathematics, the steps will be concise in the sense a lot of information can be shown in a very small area and it is accurate. So the mathematical computation skills can be made concise and accurate by using these identities. This is the first most important point, right? I hope you got it. So what is an entity? An entity is a mathematical statement or an equality which is true for all the values of the variables which are involved in it, right? That's the definition of a identity, that is algebraic identity. Second point, first point is that what is the use? First use of entity is that it makes the mathematical computations more concise and makes it accurate. Concise in the sense lot of information can be shown in a very small area which is correct, and in the sense the other word which can be used for concise is maybe very brief. Very briefly we can present the computations. Another one is it will be 100% accurate, and in the sense it will be always correct, right? So in the sense no chance of making silly mistakes or errors during the computations, right? And the second point is we get a lot of speed in that. So once we start using algebraic entities while solving mathematical problems, so we get the speed, required speed. We can save a lot of time in that. So for example, if I want to multiply 1001 into 1001, when we go for general multiplication process, it is going to take a very large number of steps and at last I am going to reach the solution. But in this place of computing 1001 into 1001 by using an identity, the process becomes very concise and accurate, and also the speed and accuracy increases. Speed and accuracy of computation increases by using algebraic identities, right? For example, I have to multiply 999 into 999, so it's a very big thing, so it takes a lot of time. But instead of doing general multiplication to multiply these two numbers, in that place I can easily use algebraic identities, which in this session I am going to derive one by one. I am going to establish them, right? By inductive method I am going to I'm going to establish each and every entity. I'm going to present you how the entity is created, how it comes, and I'm also going to teach you how we are going to apply that in our day-to-day mathematical computations, right? So, and third most important point is that, so these algebraic entities have a wide range of applications. It's not only confined to algebra. Wherever you need, wherever you want, you can apply these entities to make the computation skills concise, accurate, speedy, and accurate with lot of accuracy, right? So if all these things are involved, it's an advantage for a student to save time and to reach to the required solutions as soon as possible, right? So with these things we will enter into the first entity, which is well known, very famous algebraic entity, that is a plus b whole square is equal to a square plus 2ab plus b square. So students, please remember this first. You should not by heart these formulas. You should not by heart it. You should remember this. That's very important. And you should know how it comes, how the formula is derived. Without knowing how the formula is derived, just by hearting that and applying in the problems is the root method of learning it. So let us see how this formula is derived. That is how it is. I am going to establish how it is going to come. Let us apply that and learn the skill of computing in mathematics, right? So first, in the first step, we will be going with the very famous entity, that is a plus b whole square is equal to a square plus 2ab plus b square, right? Okay, now let us get into the establishment of the most important entity, that is a plus b whole square is equal to a square plus 2ab plus b square. So most of the people generally they go with this when they are speaking generally regarding mathematics. When I was in high school, I have learnt a formula. Oh, tell me the formula, sir. The formula is a plus b whole square is equal to a square plus 2ab plus b square. So even those people from very limited educational background, they remember this particular formula, right? Let us see how it comes. So establishment of a plus b whole square is equal to a square plus 2ab plus b square, right? So in order to establish this, in the LHS we have a square, that is a plus b whole square. So therefore we will consider a perfect square here. Okay, let us take a perfect square here. So we know that in a perfect square all the four sides will be equal. So ABCD is a square where all the four sides are equal, right? So now let the sides of this square be, as it is given here, it is a plus b. So let this side be a plus b, right? Let this side be a plus b. Okay, let this side be a plus b, and let this side also be equal to a plus b. Why I have taken all the four sides same? Because I have taken a square here. Therefore every side of the square is equal to a plus b. Now, so here we are going to improve this square by taking the sides a plus b in a different manner. So here a is a different number, b is a different number. They are two different real numbers, right? So let us take the square here, the same square we are going to take it. Okay, this is the required square. Let us take it as ABCD, the same square we have taken. So here, as a is a different number and b is a different number, from here to here let it be, that is from here to here it is a plus b. So from here to here it is, let us take it as a, and let us take it as this part as b. So this is a plus b, that gives you a plus b here, right? So in the same manner we will take a here, particularly a here. So we will take this point as until this point let us take it as a, and let this point be b, right? So here also we will consider this point, and from here to here let it be a, and let this part be b. Okay, so the same thing happens as the opposite sides are equal here. So here we will consider a point. From here to here let us take it as a units. From here to here let us take it as b units. Okay, now Let us join these 2 points here. Let us join these 2 points through a line. Let us join these 2 points and let us join these 2 points through a line. Alright. So now, very simple things happen here. So this entire thing is a plus b. This entire thing is a plus b. And out of a plus b, this part is a and this part is b. And this entire thing is a plus b. So this part is a and this part is b. And entire thing is, this is a plus b. So this part is a and this part is b. So this entire thing is a plus b. So this is a and this is b. Now let us name the points here. Let us take it as point P. Let us take it as point Q. Let us take it as point R. And let us take it at point S. So now we had a square here, but now we have the same square, but this square is divided into 4 different polygons. 4 different types of polygons we have. So here, area of square ABCD has 4 set of polygons inside it, right? One is, okay, let us name this point. Let us name this as point M. So one is the square APMS. So this is one of the polygon which is a square here. So PBQM is another polygon which is not a square but looks like a rectangle. Another one, this one is QMRC. This is another polygon which looks like a square. And SMRD is a polygon which is not a square but looks like a rectangle. Now when we add the areas of polygons, that is the 4 polygons, area of this polygon plus area of this polygon plus area of this polygon plus area of this polygon, we are going to get the area of the square ABCD. So let us do it. So area of square ABCD, area of square ABCD is equal to area of square APMS. So this area we can consider, this is the area we have taken here, right? So this is the square here, because A is equal to this A, which is equal to this. So this length is equal to this length. So as all the 4 sides are equal in this, as all the four lengths are equal, so therefore area of this particular polygon will be A into A, that is A square. This can be written like this, that is equal to area of APMS is equal to area of square APMS plus, let us get into this here. So here PBMQ is a rectangle. It looks like a rectangle because if you take this as the length, which is A units, which is opposite to this, is equal, and if you take this length as B, this is equal to this, that is this length is B. So this is a rectangle here. So the formula to find the area of a rectangle is that is length into breadth. So this is the rectangle I am identifying here. So this is the rectangle. So now area of this rectangle is A into B, that is length into breadth. So that becomes AB, A into B. So area of square APMS plus area of rectangle PBQM plus, let us get into the another polygon here. So here MQCR is another polygon here. So if you observe that, one of the side is B, another side is B, another side is B. As this is equal to this, so this length is also equal to B. So if all the sides of a polygon are equal, then it can be called as a square here. So therefore MQCR becomes a square. So let us identify that by shading this. So this is a square here. So in this square we have the area, that is B into B, that is B square. So inside the square ABCD we have identified 3 polygons here. So area of rectangle PBQM plus area of square that is QMRC, right? QMRC, right? Plus we are left over with another polygon here. So here its side is A units, its side is B units. So therefore A into B, that is, it gives you the area of a rectangle here, because A is equal to A this length and B is equal to B this length. So opposite sides are equal and one of the side is bigger than the another one. So we can see here that this is the length and this is the breadth. So length into breadth gives you area of this polygon. So here area of this polygon can be, I am going to shade this and identify that. So this is the area of this square, that is a rectangle, right? So it is named as SMRT. So area of rectangle, right, that is SMRT. Now what is the area of square ABCD? So here area of square ABCD is, side is A plus B, another side is A plus B. So A plus B into A plus B gives the area of this square. So that becomes A plus B into A plus B can be written as A plus B whole square is equal to, let us take the area of square APMS. APMS square area is A square, that is A square plus, next is area of rectangle PBQM. PBQM, area of this rectangle is AB, that is AB plus area of square QMRC, area of square QMRC, that is B square. So it is B square plus area of this rectangle SMRD. So here A into B is, the area is AB here. So we will take this AB. Now, so A plus B whole square is equal to A square plus 1AB plus 1AB is, it becomes 2AB plus this B square. So this is called an algebraic identity. This is how we get the formula, that is A plus B whole square, which is A square plus 2AB plus B square. So here, as I told you earlier, identity is an equality which is true for all the values of the variables involved in it. So here A and B are the two variables. For example, you can take, let A is equal to 2 and B is equal to any number you want, and A is equal to also any number you want. You take any values for A and B. Let it be real numbers, let it be decimals, let it be rational integers, whatever you want, you can take it. So let A is equal to 2 and B is equal to 3, for example. In this example I am going to take and I will substitute these values here. So it is 2 plus 3 whole square is equal to 2 square plus 2 into B is 3 plus B square is 3 square. So 2 plus 3 whole square is, that becomes 5 square is equal to 2 square is 4 plus 2 2s are 4, 4 3s are 12 plus 3 square is 9. So 5 square is 25 is equal to 4 plus 9 is 13 plus 12. So 25 is equal to, that is RHS. So therefore it is called as an algebraic entity. So usually 3 bars are represented, right, in between these two, that is, an entity is always represented by 3 bars written between A plus B whole square and A square plus 2AB plus B square. So here the 3 bars is read as, actually it is read as, can be replaced by. The 3 bars are read as can be replaced by. For example, if I write 3 bars like this, so this indicates can be replaced by. So this is how you have to read this. So A plus B whole square is equal to 3 bars is equal to A square plus 2AB plus B square. It is not the way to read it. So A plus B whole square is equal to can be replaced by A square plus 2AB plus B square. That is the meaning of identity. But usually in common, what has happened nowadays is that instead of using this 3 bars, we are just using 2 bars, 2, that is equals here. So A plus B whole square is equal to A square plus 2AB plus B square. For example, I want to find out the value of 300 square, for example. So this can be written as, so 300, that is 200 plus 100 whole square, it can be split like this, and we can apply the formula, that is identity here, and we can easily find out this. For example, I have to find out 97 whole square. I have to find 97 into 97. The process of multiplication is time consuming. The percentage of accuracy is very less. So therefore, instead of 97 into 97 doing that, instead of that you can do it as 90 plus 7 whole square, and apply this identity and easily reach the solution. So computational steps is going to become very accurate and it is concise, right? So I hope you enjoyed the first identity, that is a plus b whole square is equal to a square plus 2ab plus b square. This is how it comes. Remember this. Just recalling is not very important. Remembering and applying that, right, that is plays a very important role, right? Okay, now let us get into the second beautiful identity, algebraic identity, that is a minus b whole square is equal to a square minus 2ab plus b square. So in the same lines as we established the a plus b whole square identity, we will be going in the same method, but a little bit difference is in the geometrical proof. So just look into the proof very carefully, right? Okay. So here we have to establish that a minus b whole square is equal to a square minus 2ab plus b square geometrically, and then we will see how we are going to get it. So it's an important derivation. So it will be not asked in your examination for any 2 or 3 marks, something like that. It is just for your pure knowledge we are doing this, right? Now let us imagine a square. Let us imagine a square whose sides are a units. So all the sides are equal to a units. So this is a units, this is a units, this is a units, and this is also equal to a units, right? So that if the side of the square is a units, so naturally the area of the square will be a square units. Okay, a into a, that is side into side, is a square units. Now in order to derive the identity a minus b whole square is equal to a square minus 2ab plus b square, we are going to convert this square into different polygons. Let us see how it comes. Let us take the same square here. Listen very carefully, it's very important. Same square we will take. So each and every side is a units. So this side is a units. So as usual, this side is also equal to a units, because in a square all the sides are equal. So this is a units, and this is also equal to a units, right? So all the 4 sides are equal to a units. So let us name the square. Let it be AB CD. Now what is the area of this square? Very simple, side into side, that is a square is the area of this square. Now let us mark a point P. Let us mark a point P on DC such that PC will be equal to B. Let this PC will be equal to B. So now DC is A units, PC is B units, then what will be the length of DP? So it will be this length minus this length equal to this, that is A minus B. So this length will be A minus B. Very nice. Okay. So let us mark another point at same distance, that is equal to PC here, that is on AD. Let us take it as B. So if this is B units, then this will be A minus B units. This will be A minus B units. Okay. Let us take another point here, which is let us call it as PQ, and let us call it as point R. So let this be B units here. B units. So naturally this will be A minus B units here. Very simple. So let us mark another point here. Let this be point S. So let this be equal to B units. So then this will be equal to A minus B units. This will be equal to A minus B units. Now let us join this QS. Let us join this QS, right? And let us join this PR, right? So entire square ABCD is divided into 4 different polygons. So let us write the sides of these polygons one by one. So here AR, let us name this M, ARMQ is a square with side A minus B into A minus B, so this becomes A minus B whole square. What is the area of this square is? That is A minus B whole square. That is A minus B into A minus B. Now, this is RBSM. So this becomes a rectangle here with length A minus B and breadth B minus A. Then what is the area of this polygon RBSM? That is length into breadth. So that is, it can be written as B into A minus B. B into A minus B. Now, what is the area of PCSM? So this is also a type of polygon here. So when we see the sides are equal, B units, so this is also equal to, this is parallel to this, so this is equal to this, so therefore this is also B units. So all the four sides are equal here, so therefore it becomes a square. Therefore area of this square is B square units. Next is QDPM. So this is the rectangle here. So this will be the length and this will be the breadth. So area of this rectangle is A minus B into B. That becomes B into A minus B. B into A minus B. So this is how we are divided. So now area of the square ABCD is equal to area of square ARMQ plus area of rectangle BRMS plus area of square PCSM and area of rectangle QMPD. So these two are the rectangles and these two are the squares. So when we add the areas of all the four polygons, we are going to get the area of this square, that is ABCD. So let us write that. So area of square ABCD is equal to area of square that is ARMQ plus area of square that is this one, that is MSCP plus area of rectangle. Let us take this one. So area of rectangle that is RBSM plus area of rectangle, another one, that is this rectangle, area of rectangle, that is QMPD. So what is the area of square ABCD? So here every side of the square has A units, so therefore side into side, that is A into A, that is A square is equal to area of square ARMQ area, that is A minus B into A minus B, that is A minus B whole square plus area of square MSCP area, that is B into B, that is B square, right, plus area of rectangle RBSM area of rectangle, that is length into breadth, that is A minus B into B. So B into A minus B plus area of rectangle QMPD, that is B into A minus B. Right, let us simplify these things. So A square is equal to, let it be A minus B whole square itself plus B square plus B into A is AB, B into minus B is minus B square plus B into A is AB plus into minus B into B is B square. Okay, plus B square and minus B square is going to get cancelled. So A square is equal to A minus B whole square plus 1AB plus 1AB is 2AB, and leftover thing is minus B square. So let us, as we are deriving, as we are establishing the identity for A minus B whole square here, let us transpose these two terms to the LHS, right? So that becomes A square plus 2AB. On transposing to LHS here, it becomes minus 2AB minus B square. On transposing to LHS, it becomes plus B square is equal to A minus B whole square. So when we alter both LHS and RHS, so it becomes A minus B whole square is equal to A square minus 2AB plus B square. So this is the formula to the entity which is called as the basic entity, fundamental entity, that is a minus b whole square is equal to a square minus 2ab plus b square. The square of the first number subtracted twice the product of both the numbers plus the square of the second number, generalized thing. So usually our teachers used to teach us in this manner. So what is a minus b whole square is difference of two numbers square is equal to the square of the first number minus 2 times the product of the first and the second number plus the square of the second number. We used to remember the entity in this manner. So usually nowadays students, what is a minus b whole square? So a square minus 2ab plus b square. See, that is not the way actually. So it is once again the difference of squares, the difference of square of two numbers is always equal to the square of the first number minus twice the product of the two numbers plus the square of the second number. So this is a minus b whole square. For example, I have to find the product of 1001, that is 1001 whole square. I have to find the product of this. So this can be written as 1000 okay, let us take like this. Let us take 1000 square, right? So what is the square of 1000? So 1000 square can be written as 1001 minus 1 whole square. By using this formula we can go with the result, that is computation can be easily done. So in the next coming classes sessions I will be going with problems on this, that is we are going to apply that. So we are going to deduct that, that is by inductive method we have learned all these things. So in the next session will be deductive thing. We are going to deduct these things and apply in the particular formulas, apply these formulas in the coming problems, right? Like this we are going to apply this, right? So I hope you enjoyed the entire session. So both the formulas are very important. In tomorrow's session, along with the problems on this, I am going to derive 2 more entities related to your syllabus and problems on it. So until then, stay home, stay safe and keep learning. Thank you.